Electricity is the lifeblood of modern society. It is the invisible force that powers our daily lives, from the moment we wake up to the time we go to bed. Without it, our world would come to a standstill. It powers our homes, businesses, and industries. From the lights that illuminate our rooms to the computers that connect us to the world, electricity is at the heart of our modern existence. In factories, it drives the machines that produce the goods we rely on every day. Understanding the principles of electricity is essential for anyone working with electrical systems. Whether you are an electrician, an engineer, or a technician, a solid grasp of electrical concepts is crucial. It allows you to work safely and efficiently, ensuring that systems operate as intended. This is especially true for professionals in fields like electrical engineering, electronics, and telecommunications. These fields are constantly evolving, with new technologies and methods being developed all the time. Staying up to date with the latest advancements is key to maintaining a competitive edge. A deep understanding of electrical concepts allows professionals to design, install, and maintain electrical systems safely and effectively. This knowledge is not just theoretical, it has practical applications that can make a real difference in the world. For example, designing energy-efficient systems can help reduce our carbon footprint and combat climate change. It enables them to troubleshoot problems, optimize performance, and develop innovative solutions. When issues arise, a well-trained professional can quickly identify the root cause and implement a fix, minimizing downtime and ensuring that systems run smoothly. This ability to solve problems efficiently is invaluable in any technical field. This essay will delve into the fundamental principles of electricity, focusing on voltage, current, and resistance. These are the building blocks of all electrical systems, and understanding them is the first step to mastering the field. We will break down these concepts in a way that is easy to understand, even for those who are new to the subject. We will explore these concepts in detail, highlighting their practical applications and the tools used by professionals in the field. From multimeters to oscilloscopes, we will show you how these tools are used to measure and analyze electrical systems. This hands-on approach will give you a deeper understanding of how electricity works in the real world. Whether you are a seasoned electrician or just starting your journey in the world of electricity, a strong grasp of these fundamentals is crucial for success. Continuous learning and staying updated with the latest advancements will keep you ahead in this ever-evolving field. Workshops, courses, and hands-on training are excellent ways to enhance your knowledge and skills. Join us as we unlock the secrets of this powerful force and explore its impact on our world. From the basics to advanced concepts, we will guide you through the fascinating world of electricity. Together, we will discover how this invisible force shapes our lives and drives innovation in countless industries. All matter is made up of atoms, which consist of a nucleus orbited by electrons. These electrons are fundamental to the electrical properties of materials. The nucleus, composed of protons and neutrons, is positively charged, while the electrons are negatively charged. The interaction between these charges is what gives rise to electrical phenomena. These electrons carry an electrical charge. When electrons move from one atom to another, they create an electric current. This movement is the basis for electricity, and is influenced by the type of material they are moving through. The behavior of these electrons determines how a material interacts with electricity. In some materials, electrons can move easily, while in others, they are more restricted. This difference is what makes a material either a conductor, an insulator, or a semiconductor. Some materials, like copper and aluminum, are excellent conductors of electricity. This is because their atomic structure allows electrons to move freely from one atom to another, facilitating the flow of electric current with minimal resistance. This is because their electrons can move freely. In conductive materials, the outer electrons, known as valence electrons, are not tightly bound to their atoms. This freedom of movement is what makes metals like copper and aluminum ideal for electrical wiring and components. Other materials like rubber and glass are insulators. Insulators have a different atomic structure where the electrons are tightly bound to their atoms, making it difficult for them to move and thus preventing the flow of electric current. Their electrons are tightly bound to their atoms, making it difficult for electricity to flow through them. This property is crucial for safety, as insulators are used to protect us from the dangers of electric currents by preventing unintended flow of electricity. This difference in electrical conductivity is crucial in designing electrical systems. Engineers and electricians must carefully select materials based on their conductive or insulative properties to ensure the safety and efficiency of electrical systems. Conductors are used to carry electrical current, while insulators provide protection and prevent short circuits. The right combination of these materials ensures that electrical systems function correctly and safely. Semiconductors such as silicon and germanium fall between conductors and insulators. They have unique properties that allow their conductivity to be precisely controlled, making them essential for modern electronics. Their conductivity can be controlled by adding impurities, a process known as doping. This makes semiconductors incredibly versatile and essential for electronic devices like transistors, diodes, and integrated circuits, which are the building blocks of modern technology. Understanding the electrical properties of different materials is fundamental to working with electricity safely and effectively. Whether designing complex electronic circuits or simple household wiring, knowledge of how materials conduct or insulate electricity is essential for innovation and safety in the electrical field. Voltage, also known as electrical potential difference, is the force that drives electrical current. It is analogous to pressure in a water pipe. The higher the voltage, the greater the potential difference, and the stronger the force pushing electrons through a circuit. Voltage is measured in volts. In professional settings, understanding different types of voltage is crucial. Alternating current and direct current are the two main types. AC voltage, commonly found in homes and businesses, changes direction periodically. DC voltage, used in batteries and electronic devices, flows in one direction. Another important concept is the difference between phase voltage and line voltage. This is particularly relevant in three-phase systems, commonly used in industrial applications. Phase voltage refers to the voltage between a phase conductor and the neutral, while line voltage refers to the voltage between two-phase conductors. Current is the flow of electrical charge through a conductor. This movement of charge is fundamental to the operation of countless devices and systems in our daily lives. From the moment you flip a light switch to the complex operations of your smartphone, electrical current is at work. It is, well, similar to the flow of water through a pipe. Just as water flows from a region of high pressure to low pressure, electrical current flows from a region of high electric potential to low electric potential. This analogy helps us understand how current moves through different materials and components. Current is measured in amperes, often shortened to amps. Amperes quantify the amount of charge passing through a point in the circuit per unit time. For instance, a current of 1 ampere means that 1 coulomb of charge is passing through the circuit every second. The higher the current, the greater the flow of electrical charge. This can be visualized by imagining a wider pipe allowing more water to flow through it. Similarly, a higher current means more electrons are moving through the conductor. There are two main types of current: direct current, or DC, and alternating current, or AC. Each type has its own unique characteristics and applications, making them suitable for different purposes in the world of electricity. In DC, the flow of electrons is continuous in one direction. This steady flow is ideal for devices that require a constant voltage, such as electronic gadgets and battery-operated equipment. This is the type of current produced by batteries and solar panels. Batteries store energy chemically and release it as direct current, while solar panels convert sunlight into direct current electricity. In AC, the flow of electrons changes direction periodically. This alternating nature allows for efficient transmission of electricity over long distances, which is why AC is used for power distribution in homes and businesses. This is the type of current that powers our homes and businesses. The alternating current supplied by power stations is transformed to different voltages to meet the needs of various appliances and systems. Professionals use various tools to measure current, including ammeters and clamp meters. These instruments are essential for diagnosing electrical issues and ensuring systems operate safely and efficiently. Ammeters are connected in series with the circuit to measure the current flowing through it. By being part of the circuit, they can accurately measure the flow of electrons. Clamp meters, on the other hand, can measure current without interrupting the circuit by clamping around the conductor. This non-invasive method is particularly useful for quick checks and troubleshooting in complex systems. Resistance is the opposition to the flow of electrical current. It is, well, analogous to friction in a mechanical system. Resistance is measured in ohms. The higher the resistance, the more difficult it is for current to flow. Resistance is a fundamental property of materials. Conductors have low resistance, while insulators have high resistance. Resistors are components designed to provide a specific amount of resistance in a circuit. They are used to control current, divide voltage, and perform other functions. Understanding resistance is crucial in various real-world applications. For example, motor windings have resistance, which affects their performance. Grounding systems rely on low-resistance paths to divert fault current safely to the earth, preventing electrical shocks and equipment damage.